Simulating experiments. Simulation is the imitation of a chance behavior based on a model that reflects a real-world situation. To conduct a simulation, we need to describe the possible outcomes, link the outcomes to random numbers, choose random numbers. Based on our chosen random numbers, we need to record the simulated outcome and then repeat, choosing random numbers and recording the results until the desired number of trials are complete. When we're finished, we will analyze the outcomes. Example: Bessie's tour bus seats 20 people. She has discovered about 8% of people she sells the tickets to are no-shows. Wanting to avoid empty seats, she decides to sell 22 tickets for each tour. Use simulation to decide if this is a good strategy. Well, first we need to assign our digits. 8% of the people are no-shows. 8% would be 8 out of 100. So, let's assign the digits 00 to 07 for our no-shows. And 08 to 99 would be the people that show up for the tour. This gives us 8% of our two-digit numbers representing no-shows and 92% for the ones that show up. There's many ways that you can assign your values, and you just need to make sure that you state it within your problem. Now let's look at the random digit table. Pick a line and select 22 two-digit numbers from our table. So let's start on line 104. Just pick that at random. So our first number is 13. 13 is in our 08 to 99 group, so we'd have a show. Let's let our shows be represented by S and our no-shows with N. Our next two-digit number is 78, so they would show up as well. Then 51, 15, 09, still in my show up group, 54, 89, 19, 83, 75, 68, 37, 75, 05, 72, 08, 45, 38, 03, 76, then go to the next line, 80, and 37. This should be 22. Yeah. So of this 22, I have 2 no-shows. So we have 20 that show and 2 no-shows. So she would have been safe with this simulation with her number of tickets sold and the number of people to seat. But if we'd have started at a different line, would she have also made a good choice? When running a good simulation, you would repeat this several times and then look at your averages, the average number of shows and no-shows, to make the decision on whether or not she's done a good thing by selling 22 tickets per ride. Example 2. Joey's interested in investigating streaks when flipping coins. He wants to use simulation methods to determine the longest run of heads on average for 20 consecutive coin flips. Describe a correspondence between random digits from the random digit table and outcomes. Well, the smallest that we can choose from our random digit table would be a single digit. So single digits would be the digits 0 through 9. There's several possible ways we could do our correspondence between these single digits and the outcomes from a coin flip, which would be heads or tails. We could allow the digits 0 through 4 to represent heads and 5 through 9 to represent tails, or we could let the even numbers represent heads and the odd numbers represent tails. We just have to make sure that however we pick the numbers, they are the same representation of the probability of a coin flip, which is 50-50. 50% heads, 50% tails. So let's go ahead and say that we're going to use the digits 0 through 9, where an even number represents heads and an odd number represents tails. What will constitute a repetition, one repetition from this simulation? Well, he's doing 20 consecutive coin flips, so one repetition would be choosing 20 one-digit numbers. So let's start with line 101 and carry out 10 repetitions and record the longest run of heads for that repetition. So that means we're going to do 10 of these 20 coin flips, and then we'll find the mean length for those 10. So we want to start at line 101, and we said that the even numbers represent heads and the odd numbers represent tails. So we're looking at single digits. So this first digit's odd, so we have a tails, then we have an even, so that's heads, then tails, then heads and heads, and heads and heads, then tails, tails, heads. Remember, we're doing 20 tosses, so we need to do 20 digits. We've done 10 so far. Heads, tails, tails, heads, heads, tails, heads, heads, tails, heads. Now this is 20, and we want the longest run. So in run 1, the longest run of heads is right here where we have 4. Now trial 2. So we start over right here. Here we have heads, 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 tails, heads, tails, tails, heads, and heads, tails, tails, heads, tails. So our longest run in the second trial is 5 heads in a row. Third trial, we're going to the next line, and we have 1, 2, 3, 4. All of these are tails. And then we have a heads, and another tails, tails, heads, heads, tails, heads, 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 heads. There's 4 in a row right there, and just 3 in a row on this one. So 4 would be our longest streak on our third trial. Then the fourth trial, start over here at the 77, we got tails, tails, heads, tails, 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 heads, heads, tails, tails, heads, heads, tails, heads, heads. So it looks like on this trial we had only 2 heads in a row as our longest streak. And we would keep doing this ten times. We'd choose 20 two-digit numbers. Once we finish all this, then we're going to get the mean. So I run my 20 coin flip simulation 10 times now, and these are my results. Again, we started at the beginning of line 101, and every even number represented a heads, every odd number represented a tails. We counted up the ones that had the longest streaks of heads. The mean of all these streaks of heads is 29 tenths or 2.9.